See, next basic signal is a impulse signal. This function explains at particular time period the function amplitude is infinity amplitude and remaining time period it is not defined. Like this is y-axis and x-axis here. X-axis should be here time axis. This is negative time axis. Exactly at t is equal to 0, time is equal to 0, this amplitude is infinity amplitude. Infinity amplitude. So remaining time period is not defined. This side it is 0 and this side it is also 0. This signal is called impulse signal. The signal representation, x of t is equal to, this is function name, x of t is equal to infinity amplitude exactly at t is equal to 0, and the same function is 0 other than the t is equal to 0. See, exactly at time is equal to 0 at origin point, the amplitude is defined up to infinity. So x of t is equal to infinity at t is equal to 0. And this side, t is greater than the 0, positive side, and t is less than the 0, negative time axis. So other than the 0, not equal to 0, then the function is not defined. This type of signals is impulse function here or impulse signal. This signal practically is not possible. That's why in practical representation, the function is defined like this. This function is acts as a one pulse signal which has constant amplitude in particular time period with a unit area. So area of this one is 1. Area of one pulse function, area of one pulse function is 1, then it is called a impulse signal. This is practical representation of the impulse signal. This impulse signal representation is del of t. So according to this analysis, integration from minus infinity to plus infinity, del of t dt should be 1. So integration explains area of the signal. So area of this pulse signal is 1, then it is called a impulse signal. It is also called as property of impulse function. This is ideal representation and this is practical representation. And this impulse signal has certain properties, because here we consider area of this value should be 1. Due to this, internally it has some properties. Those properties are del of at. Del of at is here a is some constant. Some constant is multiplied with time. It is also called as scaling operation. So after scaling operation, the function becomes like this: 1 by a into del of t. This is one property. Del of at is equal to 1 by a del of t. Another property is area of the impulse function should be 1. So integration from minus infinity to plus infinity, del of t dt should be 1. Then another important property, integration from minus infinity to plus infinity, del of t into x of t dt. This x of t is some other function. This function is multiplied with impulse function del of t, and this gives the area. So if it is multiplied like this, then the function becomes x of 0, because this impulse function is defined exactly at t is equal to 0. At t is equal to 0, area should be 1. So if it is multiplied with any other function, that function defined at t is equal to 0 only. Like one example I am taking here, easy understanding purpose. X of t is equal to sin t function I am taking now. X of t is sin t, then integration from minus infinity to plus infinity, del of t into sin t dt. Del of t into sin t dt. According to this time axis becomes now 0. Now here this time is replaced with 0, this becomes sine of 0. Sine 0 is 0, then the amplitude becomes here 0. So from this property I wrote like this here. Similarly, one more example, x of t into cos t dt. Now del of t function is multiplied with the cos t, then it is defined at t is equal to 0 cos 0. Cos of 0 becomes a 1. So these three are properties of impulse functions. So impulse function, impulse signal is at t is equal to 0, it has infinite amplitude. This is the ideal definition, and practical representation area should be 1. So for practical representation always we have to write del of t. Del of t is also called as a unit impulse function, or we can write like this, del of t is unit impulse function. This is another basic signal.